topic which I have to discuss here is cells in series. Okay. So what is this cells in series? Let me discuss about this. See here. So first of all, let me draw one simple cell of EMF E, smaller resistance and actual larger resistance. This is a simple cell. In this simple cell, how do you find out the current passing through this cell? How do you find out the current passing through this cell? You all know that. Current passes from higher potential, that is from this to the lower potential in this direction. This is the direction of current flow. Now, I will apply Kirchhoff's law and find out what is the current passing through this cell. Okay. So, I am going to apply the Kirchhoff's law by taking a loop in a clockwise direction. Okay. So, if current and loop are in the opposite direction, we take plus I into small r. Okay, like this. So, here also plus I into capital R. Okay, opposite direction. Now, loop is in a clockwise direction. Means cell, in the cell, the direction of the cell according to the loop is from positive to negative, which is taken as minus here is going to be 0. This is called as Kirchhoff's second law. Kirchhoff's second law says that the algebraic sum of potential drops and EMFs is going to be 0 here. And you just remember, I told you many times that when current direction and your loop directions are moving against, it's going to be positive. If current direction, loop direction is same, it's going to be negative. If you get any doubt regarding when to take positive, when to take negative, I have given one small trick here. If you go along with the flood water, you will die. And if you can swim against the flood water, you will survive. Surviving is positive, dying is negative. Okay? So that's a simple technique to remember when it is taken as positive, when it is taken as negative here. I into small r, I into capital R is going to be E. So if you common out I, you will get small r plus capital R, which is going to be E. So I is equal to E by small r plus capital R. This is a simple formula. This is a simple formula to find out the currents in a simple cell. But what is going to happen when you consider a series of cells? What's going to happen when you consider a series of cells here like this? And how many cells are there here? These are n cells present here, which is connected parallel to the external resistance small r, and this is R, this is R, this is R, this is R. This is E, and this is going to be E, and this is going to be E. So here, all the cells of EMFs same, internal resistance same, are connected in series. Okay. So when they are all connected in series, okay. So what is the solution here? One thing you remember that E in series is nothing but you have to just add the EMFs. Okay. And so on, n times. So E in series can be taken as NE. Understood? N into E. Just multiplication of n with E is going to be your answer now. Then what happens to resistance when they are connected in series? This is R plus R plus R and n times it is going to be. So R in series is going to be n into R. Is it okay? Is it okay? Then you got E in series, R in series, and you have to find out what is the current passing through this total circuit which is connected in series. The simple method is, if you understand the simple circuit which is for one cell, you can write the current formula for this case where all the cells are connected in series. Then the current in this case, when the cells are connected in series, is considered as E series by R series plus capital R. That's it. Understood? The same basic formula should be considered here, and you will write now that that is I in series is going to be E in series is nothing but N into E, and R in series is written as N into small r is going to be capital R. So your answer is ready. This is ready here. So the current in the series connection is taken as N into E by small n into R into capital R. Okay. Even if I say a shortcut method to remember what is the current passing through this simple cell, what is the shortcut formula here? Why do you need not apply always Kirchhoff's law and write the equation? So instead of applying Kirchhoff's law, you all know that every cell is having some amount of internal resistance. Just like every human body is having antibodies which will have some other resistance, small amount of resistance to your diseases. As human body is having resistance to diseases, every cell is having some amount of internal resistance. Okay. So here, what is the formula to find out the current? Instead of applying Kirchhoff's law again and again, you just write E net by R net. Whereas E net is considered as just E, one single E, and R net is nothing but small r plus capital R, sum of the total resistance is what considered. Okay. For example, here if I take one more cell and one more internal resistance, this is also E1, this is also E1, this is R1, this is also R1, then what will you write? Yes, you will just write E1 plus E2 divided by R1 plus R2 plus capital R. If I take one circuit in which one EMF is like this and other is connected in the opposite direction, and they are all connected to a common resistance. This is R1, this is R2, and this is E1, and this is E2. So we can write E net by R net, whereas E net is nothing but E1 minus E2 if E1 is greater than E2. Just remember that. Okay. So when E1 is greater than E2, you write E1 minus E2. R net is R1 plus R2 plus capital. Hope you are getting me. Hope you are getting me. Okay. So this is about the net EMF. Then what happens to the current? Okay. So when n cells are connected in parallel, this is one cell having internal resistance E, another cell having internal resistance R. Okay. So like this, considered as E, and this is R. So this total system is connected to one battery. Sorry, this total system is connected to external resistance R. Okay, is it okay? So what's going to happen now? When these all cells connected in parallel, current is passing like this, it is passing like this. You have to find out what is the current passing through the circuit when cells are in parallel. When cells are in parallel. So let us compare this with a simple circuit, which will help you to solve the case very easily. So you write current is nothing but E net by R net, isn't it? E net by R net. So in the parallel connection, what is going to be the E parallel? E parallel is just E. In series connection, E series is N into E. Series is as if there are 100 students, and I am finding what is the total height of the 100 students in series connection. Means one student will stand on the other. Each student is having 5 feet of height. What is the total strength, total height of the class when the student is standing one above the other in series connection? What is the total height? 100 into 5 is nothing but 500 feet is the total height. Let us imagine the boys of 5 feet are standing in a prayer. Okay, standing in a prayer in a parallel. Parallel means one beside the other, parallel connection. I am asking what is the maximum height of the class? I am asking what is the maximum height of the class means what will you do? You will take only one fellow you will take, because they are in parallel connection. In series means one above the other, you just add them, the total length. Hope you are understanding. The cells also same case here. In the cells also same case here. When all the cells are in parallel connection, E parallel, you will take only one, because all are same here. Understood? That's the case. then what's going to happen? Then what is going to happen to R parallel? So 1 by R parallel is nothing but 1 by R and all the resistors same. So 1 by R plus 1 by R and so on is going to be N by R. So R parallel is going to be how much? Okay, ilane N times undi, N times. Okay, it's going to be N by R. Just like you write N into 1 by R, is it? So R parallel is going to be how much? N by R. So R parallel is R by N. Okay, you just apply the simple circuit formula here also. Like I in the case of parallel connection is nothing but E parallel by R parallel plus external resistance. So I parallel is going to be E parallel. E parallel is how much? E parallel is just 1 E you will consider because all are in parallel. So E parallel is 1 E. R parallel is R by N plus capital R which is connected in series. Okay, so this is the case in I parallel. So I parallel, if you take an LCM, you will get R plus N into capital R by N into, in the numerator is E. Okay, so what do you understand from this? What do you understand from this? I parallel is nothing but N into E by R plus N into. Hope you understand. So what is the difference between I series and I parallel? What is the difference between I series and I parallel? See, if you consider I series, we write N into E by N into R plus capital R. If you consider I parallel, N into E by R plus N into capital R. This is the small difference here. In the numerators, both are getting N into E, N into E. But in the denominator, in series connection, as all the resistors are in series, we will write N into R plus capital R. Here, you will get R by N, no? Why you are getting like this? Because I parallel is nothing but E by R by N plus capital R. Okay, so this N will be transferred to that R and this denominator is transferred to the numerator. So that's the small difference between these two. Is it clear? Is it clear? So what is going to happen at the combination of series and parallel? You just see here, this is one cell, this is one cell. Like this, how many series are there? There are N times. There are N cells connected in series, and these type of series. Why should I use all this? I should use technology. Okay. Now just see here what's going to happen. See, N series and this type of parallel circuits, how many are there? M parallel. Okay, for example, if 5 parallel circuits. This is 1, 2, 3, 4. Okay, 4 parallel. So 4 sets are parallel. Like this 1, 2, 3. So 3 are in series. So what do you understand from this? So 3 is taken as N, 4 is taken as M. Hope you understand. And the total circuit is connected to an external resistance. So from this you should get the final answer. What is going to be your final answer? Let me see here. What is going to be your final answer? Okay, the final answer is you have to use the total system. I series is nothing but N into E by N into small r plus capital R. I parallel is nothing but N into E, and this is small r plus N into capital R. You just remember in N series R plus R plus R plus R plus will get. So N into small r you write. In R parallel you get R by N. So R దగ్గర N ఉండదు, మిగతా చోట వెళ్ళిపోతుంది N. You just remember this one. Now this is a combination of series plus parallel. You have to use this combination and use now. See, N parallel, N is there 2 times. But here M is parallel, N is so to differentiate N and M, because M parallel sets and N cells in series. Hope you understand what I am saying now. So instead of this N, I will write N only, and instead of this N, I will write M, because M are parallel, and E is common. Okay, and here this N is representing the series connection, so I will write N into small r, and this N represents the parallel set, so I will write M into capital R. Your answer is ready. That's it. Is it clear? Is it clear? So this is the total solution for n cells in series, and the type of n sets of series are parallel. Is it okay? Yesterday I asked the doubt regarding this, where two cells were in series and at last there was one Kepler. Internal resistance also Kepler. Last or not? The same thing here. So this is the total system of cells in series and parallel. Okay, so let us imagine that here, how many cells are there total, having each and every cell an internal resistance like this. Okay, among that, see, now just see in this, totally how many cells are there here? N cells are there, and this M cells are wrongly connected. Okay, their direction is changed, they are wrongly connected. Understand? So what is the total E now? E net is how much? What will you do? Huh? See, N first thing is N cells are in series, no? Okay, so you'll write N. Okay, ఇప్పుడు correct connection ఇవే కదా, even a correct connection, అవి wrong connection కదా. So how many are correct? N minus M are correct. M are wrong. Am I right or not? In total N cells, N minus M are wrongly connected. ఎందుకు తీసేయాలి కదా, wrong connection తీసేస్తే మిగిలినంత N minus M. So here N minus M are connected like this, where the remaining M cells are connected wrongly. So M into E, I will change the direction. These are positive, they are negative. Divided by the internal resistance are they, divided by R net, total resistances. So these are all in series. So N into small r plus, this is Kepler. That's it. So N into small r plus Kepler. So therefore, this is, I am getting now I wrongly connected cases. So in wrongly connected cases, E net is this one, R net is this one. Hope you are understanding what I am saying now. Is it? Okay. So therefore, I, in the case of wrongly connected cases, is N into E minus M into E minus M into E divided by N into small r plus Kepler. So this implies that from this it is clear that I is equal to N minus, okay, so N, if you common out E here, minus 2M into E divided by N into small r plus Kepler. So this is the total combinations of all the cells in series and parallel cases. Hope you are understanding. Is it clear? Next thing is, what is electrical power? Electrical power. Okay, so everyone knows that what is the basic formula for power. Power is nothing but work by time, or it's nothing but rate of doing work. It's nothing but rate of doing work. Is it so? Yeah. So therefore, you all know electric potential is nothing but work done on unit charge. Work done on unit charge. So therefore, W is nothing but V into Q here. So power P is nothing but work by time, which is nothing but V into Q by T. And you also know that I is equal to rate of flow of charge. Q is nothing but I into T here. So P is nothing but V into I into T by T. T gets cancelled. The basic formula for power is nothing but power is a product of voltage and current. Power is a product of voltage and current. Okay. Okay. Then after that, how many types of formulas are there for power? So let's discuss here. You also know V is equal to IR according to Ohm's law. If you substitute that one here, I into Kepler into I, which is nothing but power is equal to I square R. Is it okay? So this is going to be the second formula. But you also know I is equal to V by R. I is equal to V by R. Power is equal to I plus V square by R square into R. You are substituting this I here, isn't it? Is it okay? So power is equal to V square by R gets cancelled now. V square by R is going to be your third formula for power. Hope you are understanding what I am saying now? Yes. Then after that, here, see, for example, there is a bulb like this, and here it is 230 volts of power supply is there. In India, 230 volts of power supply will be there in houses. Household potential is this one. Now this is a bulb, and on the bulb it is written 100 watts. How much it was yesterday?
100 volt, 500 watt.
500 watts and 100 volts. Okay, it is written on the bulb 500 watts, 100 volts. That is given. That is written on the bulb itself. What is the meaning of this representation? If you supply 100 watts of power, 100 voltage to this bulb, it will glow with the power of 500 watts. That is the meaning of that. That is called as power rated. Power rated on the bulb. That is called as power rated on the bulb. So this power rated on the bulb, what is the formula for power? Power is equal to V square by R. So this is called as power rated formula. Here V you have to use this formula. For V you have to use this formula. To find out the power rated, you have to use 100 into 100 divided by R. So here from this you will understand what is the resistance in this bulb. So power rated is 500 divided by V square by R. R we have to find out. So R is equal to 100 into 100 by 500. By using this formula you get what is the resistance across this bulb?
20.
Is going to be 20 ohms. Okay. So this is called as power rated. Then how do you find out power consumed? How do you find out power consumed? See, if you supply 100 volts, then only it will go with 500 watts. But if you supply 230 volts, what happens? For that, this is called as power consumed. So to find out the power consumed, the same formula if you use V square by R, at that time you should not use power rated voltage, you have to use power supplied. Power supplied gives you power consumed. Therefore, you write V square means 230 into 230 divided by R, which is nothing but 20. Hope you understand what is the difference between power rated and power consumed. Is it clear? Okay, let's start. Start doing your problems. After one more hour, if any doubts are there, I'll discuss about the remaining topics. Okay, come on, start. I thought explaining less and making you do more because you are panicking. Less time is there. You are started crying. Time is less. It's true.